Now, today, second unit is finished with the beta and gamma functions. Now, third unit, functions of several real variables. And in third unit, unit 3, functions of several real variables. Several real variables. In this one, the first topic is functions of two variables. Okay, before going to functions of two variables, let us see what is meant by function of two variables, function of three, in general, function of n variables. Function of n variables. The first definition, if to each point x comma y of a part of the xy plane, or you can write small xy, part of the xy plane, where x comma y both belongs to real numbers, x comma y both belongs to real numbers, and such that the point xy belongs to two-dimensional. Belongs to two-dimensional means one can write r into r. The notation is r square. R square stands for two-dimensional plane. There corresponds a real value z according to some rule, according to some rule f of x comma y, according to some rule f of x comma y, then f of x comma y is called a real valued function, of two variables, a real valued function of two variables, x and y, and is written as, and is defined as, simply written or defined as z equal to function of x comma y, z equal to function of x comma y, x y both belongs to r, okay. Let me explain this. The point is, first one, for every point x comma y of xy plane, this is xy plane, x-axis, and this is y-axis. For any point wherever the point is there, okay, for any point x comma y where x and y are real numbers, there corresponds a value z. Z equal to what? Z is connected to f of x comma y with some condition. Z is connected to, that means simply saying, for every point x comma y, here x comma y is there, for every point x comma y, there must be some rule or there must be some connection between x and y which gives a real value z. For example, if I consider z equal to x square plus y square, yes, this is some rule. That means x square, sum of the squares of the x and y. That is, I am denoting z as another real number. That is some rule. Or z equal to something, x square y square by some 10, like that. That means x and y are connected by some rules and it gives another real number z. Then z is called function of two variables x and y. Function of two variables x and y. And x and y are called independent variables, and z is dependent variable on x and y. You know this. X and y are called independent variables, and z is called dependent variable. In general, this is function of two variables. In general, if z equal to some function of x1, x2, and so on, xn, in general, z equal to, where all xi belongs to R. I is from 1 to n. I is from 1 to n. That means x1, x2, and xn. All are real numbers. In general, z equal to f of x1, x1, x2, xn is called function of n variables. Is called real valued function. Real valued function of n variables. Okay, and this particular form, and this z equal to f of x1, x2, and so on xn is called explicit form. Is called explicit form. Is called explicit form. What is meant by explicit form? Means what? Z is obtained from, z is you write like this, z is obtained from x1, x2, and so on xn. That means clearly dependent variable is obtained by the values of the independent variable. That is called explicit form. And if I write, for example, the function is like this. You say some phi of z comma x1 comma x2 comma xn equal to 0 is called implicit function. Is called implicit function. Is called implicit function. Means what? We cannot separate z and x1, x2, xn. Okay, z1, z, x1, x2, xn are combinedly mingled in the function phi. For example, if I write x square plus 2zxy plus y square equal to 0, y square equal to 0. Okay, this is called implicit function. This is called implicit function. You can put z here also, some z square here. Just wait, someone is logging. Now this is called implicit function. This is called implicit function, like that. Explicit function means clearly the dependent variable is purely defined in terms of independent variable. Implicit function combinedly defined. X and y, z are interrelated. X, y, z are interrelated. This is called implicit function. Now, function of two variables. Now we are dealing with function of two variables. Function of two variables. What is this? What is function of two variable? Consider the function. What is that? Z equal to f of x comma y. Z equal to f of x comma y. Take this one. Then here domain and the range. Let us see the set of points. The set of points x comma y in the xy plane. The set of points x comma y in the xy plane for which the function is defined. F of x comma y is defined. F of x comma y is defined is called domain. Is called domain. Domain of the function is called domain of the function. And this domain may be in this domain belongs to entire xy plane or some part of the xy plane. Some part of the xy plane. And the collection of the corresponding values. The collection of the corresponding values of z. That means for every x comma y, there will be a point x. Such points, collection of such points z is called range. Is called range of the function. Is called range of the function. Okay. For example, saying if I consider z equal to something 1 by x square minus y square. Z equal to 1 by x square minus y square. Okay. What is the domain here? Domain, I can take any x and y, right? So domain is what? The domain is this, the x square minus y square should not be 0. Okay. Domain means you write like this, set of all the points set of all the points x comma y such that what is this must be? This denominator should be not equal to 0. That means x square minus y square not equal to 0. So y not equal to what? Plus or minus x. Y not equal to what? Plus or minus x. That is the domain. Okay. And what is the range? It is clearly R. Range is what? Set of real numbers. Okay. Set of real numbers. Same logic if I consider some logarithmic function. Logarithmic function. Say z equal to log of some xy or x plus y, x square plus y square. What is the domain here? Domain must be this x plus y must be positive real number. X plus y must be positive real number. And what is the range? Definitely it is real number system R. Okay. So for a same logic as in function of single variable. In function of single variable, what is this? Y equal to f of x. Domain range. You know, domain range of function of single variable in intermediate level. Now this is function of two variables. Function of two variables. And the next point, neighborhood of a point. Neighborhood of a point. Neighborhood of a point. What is here? Let P, some particular point I am considering, P x naught comma y naught be a point in R square. What is meant by R square? Two-dimensional plane, nothing but xy plane. That is, I will write here xy plane. Then the delta neighborhood, the delta neighborhood of the point, P x naught comma y naught. What is it is? It is the set of all points x comma y. What is the condition here? It is the set of all points x comma y which lie inside. The points are what type? All points which lies inside a circle of radius, delta, with center at x naught y naught, Okay, this is called neighborhood of a point P. This is called delta neighborhood. In particular, it is called delta neighborhood of a point P. To understand this concept, see, just roughly I will put a figure. This is xy plane, x-axis, and this is y-axis. Okay, let me consider, don't take this as origin. Okay, let me draw separately. Okay, this one origin. I'm considering point P here, px comma y. Otherwise, you write like this to understand this. See, I'm considering this is the point P x naught comma y naught. With respect to this point, draw one horizontal line, vertical line. Okay, and what is the delta neighborhood means what? With radius delta, this is delta radius. With radius delta, draw a circle. And one more point. First let us draw a circle. Draw a circle with a delta radius like this. Then what is this point? See, this is nothing but x-axis. This is horizontal, this is vertical, right? In a horizontal line, which one varies? Only x coordinate is varying. So this is x naught, and this is positive, means this is what I can write, x naught plus delta, and y coordinate is fixed on x-axis. Okay, similarly, what is this point? This is on y-axis, vertical line. So what is this point becomes? This is x naught is fixed and a positive side, therefore this neighborhood point is x naught plus y naught plus delta. And coming to this is negative side, therefore x naught minus delta comma y naught. Coming to this is x naught y naught minus delta. So these are the neighboring points. And What is the region? This is, you draw like this. Okay. Now, this is the radius. Whatever the points are here within the circle of radius, all the points which lie inside a circle of radius delta, that means all these points, whatever the points are there, you can consider here, 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 somewhere, whatever it is, all those points are belongs to delta neighborhood of point P. Delta neighborhood of point P. The delta neighborhood is denoted by NBD. I will write. Delta neighborhood is denoted by N delta P. N delta P, N stands for neighborhood, delta stands for radius delta of point P. Okay, or someone can write NP delta. Better use this notation, NP delta. Then, what is how to define this delta neighborhood? N delta P is equal to, what is this? Delta neighborhood means what? Set of all points such that, set of all points x comma y such that, how these all points lies what? Clearly it is given. All points lies within your circle of radius delta with center x naught y naught. So what is the equation of the circle with center? X naught y naught, x minus x naught, y minus y naught whole square. Okay, equal to r square, and lies inside means less than delta square, less than delta square. If I write delta only, this is called delta neighborhood of a point P. This is called delta neighborhood of a point P. Okay, this is important. Or one can also define as R. You can define neighborhood of point P in a simple manner. This is set of x comma y points such that, what is that? The x minus x naught, any point x about x naught, its distance must be less than epsilon. Same logic, y minus y naught is also less than epsilon. This is also important. Okay, what is that? X naught, y naught, and x comma y. This okay, this x comma y, this x and this y, or any point. These are the any point in the region, and the distance between x and x naught is less than delta. The distance between y and y naught is less than delta. Okay. Now, what is the next one? This is called delta neighborhood. Next one, yeah, limit concept. What is the limit concept? Now, we know limit of a sequence. Okay, in the first unit, limit of a sequence. Now, coming to in function of two variables, limit concept. In function of two variables, limit concept. Limit of a function of two variables. Let z equal to f of x comma y be a function of two variables. Be a function of two variables. Two variables defined in your domain, some domain, and let it be some notation D, domain D. Let point P x naught y naught be a point in the domain, be a point in capital D, in the domain D. Now, if for a given real number, for a given, if for a given real number, epsilon greater than 0, epsilon is very small positive value. Okay, so however small, epsilon is very small positive value, however small, we can find a real number. We can find a real number, another real number, delta greater than 0, such that delta greater than 0, such that for every point, such that it is not here, for every point x comma y, for every point x comma y in the delta neighborhood, NBD of p x naught y naught, of p x naught y naught. What is the condition here? The function, original function minus limit L is less than epsilon, whenever this radius x minus x naught whole square plus y minus y naught whole square is less than delta, then the real finite number L is called limit of the function f of x comma y as x comma y tends to x naught y naught, x naught comma y tends to x naught y naught, and symbolically we can write this is limit f of x comma y, x comma y tends to x naught y naught is equal to L, okay. And what is this? You can write, or you can represent this is limit f of x comma y, x tends to x naught, y tends to y naught equal to L. X tends to x naught, y tends to y naught is equal to L. Now let me explain this. Before going to the explanation of limit, just roughly I will tell what is the in sequence. Already we have now in sequence what is the limit definition. Limit an as n tends to r, either otherwise in intermediate. Okay, let me explain this. This is equal to L. How we define this? Do you remember? What is this? Mod an minus L. The difference between these two is very small whenever this n goes to infinity. And in single variable function, you know, limit f of x as x tends to a is equal to L. Then how to define this? Mod f of x minus L is less than epsilon. The difference between, absolute difference between these two is less than epsilon whenever this difference between x and a is very small. What is the meaning of this approach? Just roughly, this is x and this is a. Corresponding to x, the function is here, and corresponding to a, the function value is here. When x is approaching a, this means what? X minus a means the difference between x and a is very small. Then the corresponding difference between f of x and L also very small. That is called limit approach. Same logic here also. When n is tending to when n is moving towards infinity, going to larger values, the difference between a and L is very small. Okay, just a rough idea. Using this idea, now function of two variables limit. What is here? Z is function of two variables defined in one domain, and I'm considering one point. I'm defining the limit at the point x naught y naught. Okay. Now, therefore, same logic. What is this? This L is called limit of this function. So that this difference between these two is very small. Whenever, what is actually, you can write like this also here. Whenever this x minus x naught mod, the difference between x and x naught, and y minus y naught is also less than epsilon. You can write in this way also. Whenever x, the difference, see, x comma y going to what? X naught, y naught. So the difference between x minus x and x naught, y and y naught is very small. Then the difference between function and L is also very small. A simple definition, right? So mathematically, I can write what? Limit when xy approaches to x naught, y naught, f of x comma y approaches L. L is called limit of the function. Okay, either you use this one or you use this definition, limit. Okay, and the next one, when deleted neighborhood is there. What is meant by deleted neighborhood? I will write this one. Is it necessary? Let me tell. Okay, no problem. Mm, note that note that for the limit to exist, for the limit to exist, the function for the limit to exist, the function f of x may or may not be defined, may or may not be defined at the point x naught y naught. So the function may be defined or not defined at x naught y naught. Okay, the limit, for the existence of the limit, the function may or may not be defined at that particular point x naught y naught. For example, if f of x comma y is not defined, for example, the function f of xy equal to 1 by x square minus y square, 1 by x square minus y square. It is not defined at what point? Y equal to plus or minus x, like that, or 0 comma 0. If f of x comma y is not defined at px naught y naught, then we write how the defined, then we write limit is defined as same definition, there is no change, only the change is epsilon whenever previously what we have written, x minus x naught whole square plus y minus y naught whole square less than delta, and this must be greater than 0. This value must be greater than 0. That is called this is called deleted neighborhood of point P. Deleted neighborhood of point P means this point P x naught y naught is there, right? And with respect to radius, I have draw this. And if I omit this P, if this P is not included, in this neighborhood, this is neighborhood of point P, in which the point P is not there, then that is called deleted neighborhood. Deleted neighborhood of P. Deleted neighborhood of P. Then you put P greater than this radius, this value is greater than 0 and less than delta, means this point is not included. Okay, only this is the change when the function is not defined. And this definition, entire this definition, not only this, okay, the original, this entire definition, this one also is called, this entire definition is called delta epsilon approach, is called delta epsilon approach for the existence of the limit. Delta epsilon approach for the existence of the limit. For the existence of the limit. This is one model. Okay. I will not go thoroughly in this concept limit, because just concept is important. Okay. Roughly, I will tell one problem to wonder how to deal with the delta epsilon approach. Let us see. No, not this. Yeah, one more point. You take this one also. It is required. Now, remark. What is that one? Limit exists means it must be unique. Remember, limit exists means it must be unique. Let x equal to r cos theta, polar coordinates, y equal to r sin theta, x equal to r sin theta. Then what we have, x square plus y square equal to r square, and what is tan theta, and theta is nothing but tan inverse over tan inverse of y by x, tan inverse of y by x. Then we define limit as, limit r tends to 0. See, only r tends to 0. Remember, And what is f of x comma y? F of x comma y. X means what? R cos theta. This is r sin theta. R cos theta, and this is r sin theta. F of x comma y is over, and L less than what? Epsilon. Less than what? Epsilon. Whenever what is the radius here? Under root of x minus x naught plus y minus y naught. That means r. Radius is less than delta. Radius is less than delta, which is independent of theta. Remember, independent of theta. So if in calculating Cartesian coordinates, if limit is complicated, then you transform the limit to polar coordinates. And in polar coordinates, what? In the function, you substitute x equal to r cos theta, y equal to r sin theta, and L value, this will be given. Prove that like that. I will show one problem. Less than epsilon, whenever, what is this condition? Remember, radius is less than delta. And one more point. This is first point. Now, second point, this is important. Second point, concept is important. Since x comma y tends to x naught y naught, x comma y tends to x naught y naught. This is in 2 dimension. That means I will show here. For example, x comma y point is here, x comma y. Just roughly I am telling to understand the concept. X naught y naught. These are the 2 points. Take this as A and this as B. Xy tends to x naught y naught along what path? Maybe straight line, right? Maybe straight line or some another path, right? Since it is 2 dimension, not single dimension. In single dimension, y equal to f of x, a function of x means only the limit approaches. Let me explain. Let me explain here. See, limit f of x tends to a equal to L. This means what? For example, this x, this is the point A, and this is x-axis. X approaches A through left side or through right side, means x tends to a plus or x tends to a minus. This is rough. Okay, along what? Along straight line only. Remember this one, along straight line only. Okay, this is in 1 dimension, along straight line only. But in 2 dimension, this xy tends to x naught y naught along any path, choice is yours. Okay, this is concept of a 2-dimensional limit. Xy approaches to x naught y naught, not only a single path, along any path. But since what is the limit must be? Limit must be unique. Limit must be unique means this limit of the function f of xy, when xy approaches x naught y naught, along any path, the value must be same. Xy tends to x naught y naught along any path, but limit value must be unique. You take a straight line path, parabola path, or any other path, the limit value when xy approaches x naught y naught must be unique. This is the important point. So now let me write. Since x comma y tends to x naught y naught in 2 dimension, in 2-dimensional plane, there are infinite number of paths. There are infinite number of paths joining x comma y to x naught y naught, x comma y to x naught y naught. And since the limit is unique, the limit is unique, the limit is same along all the paths. The limit is same along all the paths. Okay, this is important. Along, in problems we use this concept, along same path. Therefore, the limit is independent of the path. Limit is independent of the path joining xy to x naught y naught, xy to x naught y naught. Okay, And to understand the delta epsilon concept, let me try one problem. Say this. Using delta epsilon approach, show that first one, limit xy tends to 2 1, that means x tends to 2, y tends to 1 of the function 3x plus 4y. What is the value? You know, 6 plus 4, 10. But we have to prove using delta epsilon approach. Second one, limit xy tends to 1 comma 1, x square plus 2y equal to 3. X square plus 2y equal to 3. Solution. You can substitute directly, that is short technique. But when the question is delta epsilon approach, how to proceed? First one, what is f of x comma y? 3x plus 4y. 3x plus 4y. First thing, it is defined. Yes, is defined. Is defined at what point? Clearly 2 comma 1. So one part is clear. Then what I have to consider? F of x comma y minus L less than epsilon. By the definition, we have less than epsilon whenever what is this? X minus x naught whole square plus y minus y naught whole square under root less than delta, or what is this? X minus x naught less than delta, y minus y naught less than delta. Okay, now so let me consider this part first. Consider f of x comma y minus L. That means what? 3x plus 4y minus 10. 3x plus 4y minus 10. So let me get these terms. Remember, x minus x naught, y minus y naught. What is x naught here? 2. Y naught is here what? 1. So let me express this one. 3. Okay. 3 into 10 is there now. Let me write in place of x minus x naught, that is 2. Okay, plus 4 into y minus 1. This is compulsory. Express the expression in terms of x minus x naught and y minus y naught. That is the logic. Next, how much remaining? This is minus 6 and this is minus 4. This is minus 6, minus 4. Finished. So minus 10 is finished. This is the mod. And you know this principle. Mod x plus y is less than or equal to mod x plus mod y. Mod of x plus y less than or equal to mod x plus mod y. So this is x and this is y completely. So less than or equal to how much? Less than or equal to 3 into x minus 2 plus 4 into y minus 1. 4 into y minus 1. Okay. Then if we take, what is the condition? X minus x naught less than epsilon less than delta, y minus y naught less than delta. So you consider that. If we take x minus 2, how much? Less than delta. And another one also, y minus 1, I have to consider compulsory less than delta. In the definition itself, whenever is there. Therefore, you must consider these differences. X minus 2 less than delta, y minus 2 less than delta, y minus 1 less than delta. Then what is this becomes? F of x y minus L is less than or equal to how much? How much? This is 3 delta plus 4 delta. This is 7 delta. 7 delta. Okay. This implies what? Mod. What is this function? 3x plus 4y, and this is minus 12 less than or equal to 7 delta. Now this is less than. So this is what you write less than only. Less than or equal to becomes less than. So less than 7 delta. Less than 7 delta. And what is this is actually what we have? Mod f of x comma y minus L is less than epsilon. Therefore, this you write like this. Okay, in bracket since. Therefore, this is less than epsilon. This is less than epsilon, which satisfies, this implies, I am writing clearly, 3x plus 4y minus 10 is less than 7 delta. Definitely it is less than epsilon. When it is possible, less than epsilon, which is satisfied, which is when this less than epsilon, 7 delta less than epsilon is satisfied when 7 delta less than epsilon means what? Delta is less than epsilon by 7. This is the corresponding value of delta. That's it. This is the proof of, that means what? We are proving, we are finding delta value. We are finding this delta value, okay, corresponding to epsilon. So what I'm getting, delta equal to epsilon by 7. Hence, you conclude this. Hence, limit x comma y tends to what? 2 comma 1 of 3x plus 4y is equal to 10. Equal to 10. This is what is the one for delta less than epsilon by 7. Okay. And coming to second one. What is the function? F of xy is equal to what? X square plus 2y. X square plus 2y. It is, what is the point? 1, 1. Clearly it is defined. Defined at 1 comma 1. If it is not defined, you write not defined. Okay. Now, what is this function? First, let us consider this point, f of xy minus L. And what is the given? It is x square plus 2y. And what is the limit value is given in the problem? 3. I think 3 only. Yeah, 3 is given, right? Oh, this is minus 3. This is minus 3. And here, what is x naught, y naught? 1 comma 1. So what I am getting, x minus x naught means I have to get what terms? X minus 1. Y minus y naught means I have to get mod y minus terms in this expression. Let us try to get those terms. Now, whole square is there now. So let me write add and subtract 1. Same logic here also. When it is not possible, just to get this my x minus 1 term, I'm adding and subtracting. That's it. Your choice. Your logic is yours. Y minus y. This is over minus 3. This is mod. Next one. Expand this. A minus b whole square. So x minus 1 whole square plus 2ab. 2 into x minus 1 plus b square plus 2 into y minus 1 plus 2 minus 3. So this is mod x minus 1 whole square, 2 into x minus 1, 1 plus 2 constants are getting cancelled. Next, plus 2 into y minus 1, 2 into y minus 1. Okay. So already, you know, I told you mod x plus y plus z is less than or equal to individual mods plus z. This is the principle. Okay. So this is less than or equal to what? Mod x minus 1 whole square plus 2 into mod x minus 1 plus 2 into mod y minus 1. 2 into mod y minus 1. And remember, what is this? Whenever condition is there. What is this value? X square plus 2y minus 3. Take this as 1. If we take, we have to consider this. If we take mod x minus 1 less delta, this is compulsory. I already told you this one. That is the condition, mod y minus 1 less than delta for the limit. Whenever these conditions are satisfied, then this mod value is less than epsilon. Mod x minus 1 less than delta, mod y minus 1 less than delta, we get, what is this becomes? 1 implies mod x square plus 2y minus 3 is less than now. This is less than or equal. Now these values are less than. What is this value? X minus 1 less than delta means delta square here. Here you will get 2 delta, and here also you will get 2 delta. So totally what I'm getting, x square plus 2y minus 3 is less than how much? Totally delta square plus 4 delta, delta square plus 4 delta. Now mod x square plus 2y minus 3 less than, what is actually mod f of x minus L is less than epsilon. Therefore, you take less than epsilon, which satisfied, when it is satisfied, which satisfied when this one, what is this? Delta square plus 4 delta less than epsilon. Delta square plus 4 delta less than epsilon. Okay, one can write this is delta plus 2 whole square minus 4 less than epsilon. Okay, that is equal to delta plus 2 whole square is less than epsilon plus 4. Epsilon plus 4. I need delta value. What is finally? This is important. We need delta. That's it. This is important. So get delta from this expression. So what is delta plus 2 becomes less than square root of epsilon plus 4. Right? So what is the value of delta? Delta is less than under root epsilon plus 4 minus 2. Okay, so for this value of delta, hence limit xy tends to 1 comma 1 of what function? X square plus 2y equal to 3 when delta is less than under root of epsilon 4 minus 2. Epsilon plus 4 under root minus 2. Okay, this is delta epsilon approach. Delta epsilon approach. Okay, this is a concept of limit of function of two variables. Still many problems are there. What is based on independent of path of limit tending to. Based on this remark, xy tends to x naught, y naught, limit must be unique along any path. That's easy one actually. Okay. This is the concept of limit, and some more problems tomorrow I will tell you. Tomorrow means Monday. Okay. All of you, when you are coming to college?
Sir, is college from Monday or Tuesday, sir?
Tuesday.